this next problem. And what's weird about this problem, and maybe you won't find this to be weird, but every problem we've done, the period has been 2 pi. I think the last one was 4 pi. This one, when you go to do the period, we have this period formula, which is 2 pi divided by b, and the b in this problem is pi. So what you end up with is just a period of 2. So plain old 2, not 2 pi, just plain old number 2. And what I told you was always draw 4 lines, no matter what the period is. Okay, the period was 5, draw 4 lines and put a 5 on there. And then if you're ever wondering, like, well, how long is each space? So it's really simple, because sometimes people overdo it with, like, trying to figure out these spaces. There's 4 spaces, just divide by 4. So 2 divided by 4 is a half, so each space is 1/2. It doesn't really make a difference too much on this one, how much a space is worth, but a lot of times you need to know, like, how much a space is. Okay, the highest we need to go is 3 on this, because the amplitude is 3. We do not have a shift up or down, but when you're doing your amplitude and you're scaling your y-axis, take that into account, that sometimes you have to go higher than that number. Make sure you have at least one number on the y-axis. Okay, you should be able to do this one all in one graph. You shouldn't need to do 2 or 3 graphs. Now, let me explain what we didn't do here so that you understand. What we didn't do is graph normal cosine and then shrink it down from a period of 2 pi to a period of 2. We just relabeled where we would have put 2 pi, we just labeled it 2, and that changes the period. So we don't graph it and then shrink it. We just change the label and it shrinks itself. So cosine normally starts at 1, but I'm starting at 3. And I'm going to make this V shape here. And so just by labeling the axes like this, I took care of the amplitude, I took care of the period. So you can usually do amplitude and period all in that first initial graph that you make, which is all that you need for this one. Any question about that one? That one's it. That's it for that one. What I wouldn't want people to do is graph this at 2 pi and then try to shrink it down, which is what happens. That's what that pi does. It shrinks it down into 2. It wouldn't be helpful to do that anyway. So, any questions about this one? Okay, so I'll leave it up there for a second, and then we're going to move on to the next one. I would call this one, maybe moderate level of difficulty, sitting with the last one, and then this next one is going to be considerably more difficult. This one has everything in it, okay? It has a change of period, a change of amplitude, it has a flip, a shift that's horizontal, and a shift that's vertical. It's got everything you could ever ask for in a problem. All right, so before I do it, why don't you write down what you think the amplitude and period are? This graph is a little bit larger than probably what we need. I'm still going to draw 4 lines on each side, so there's probably going to be a lot of this graph that I'm not going to use here. So you could draw 4 lines, and whatever the period is, that goes in that 4th line. So the way you find the period, and I'll do the work over here, the period is 2 pi, which is the original period of cosine, divided by the number that's right here. Okay, that's the b value. And so you should write pi. You're going to label this pi. When you go over here, make sure you don't accidentally label this pi also. Sometimes people just label it pi and pi instead of negative pi and positive pi. the amplitude is always positive. So if you wrote -2, erase the negative. Probably a lot of people have wrote -2, and that's okay. Just change it to +2. When you do phase shift, you have to make sure that that number that's added or subtracted is added or subtracted just plain old x. If that was a 7x or a 2x or a 1x there, then we have to factor that number out. We talked about that earlier. But the way this one is in the way we want it to be. So there's nothing to show you here other than that's the C. And just yell it out. Is that pi over 4 right or is it pi over 4 to left? Left. Plus is left. So I wouldn't write negative. I would just write left. Okay. It doesn't say here, up or down, but I'm going to make a little note that this one goes down. Well, I guess I'll write down 1. This one's going to be a down 1. All right. So we don't do all this stuff at once. It's too much stuff to do all in one thing. So I am going to draw, let's see, the amplitude is 2. There's a shift down 1. So I think I'm going to draw 3 lines going up, although I won't need that much. And I'm going to draw 3 lines going down just so it's symmetrical. And I will need to go down to that -3. The amplitude is 2. That means it goes from -2 to 2, but then it goes down 1. So that's going to bring you down to -3. Any questions about anything so far? Okay, now you have to decide what you're going to do next. Okay, you're not going to do the shift down. You're not going to do the shift left. Do you want to do the amplitude of 2 and the period, and then later flip it? Or do you think you could handle all that at once? Because really, the part we do next without the flip is really straightforward. Because we label these things to be correct. So those dots that make that V shape, they're ready to go. If I were to change this period to something else, I mean, I would, the label here is not really affecting what I'm doing. So if you think you can flip it at the same time, flip it. I'm going to do this, and I'm going to flip it next. So this is cosine with an amplitude of 3. No, I'm doing it wrong. Why is somebody telling me? Amplitude's 2, right? Yeah. Okay. So I'm maybe putting that 3 there was a mistake because it almost made me graph a 3. Amplitude of 2. So starting at 2, going down to -2, and going back up to 2. And then period of pi, is taken care of. Now this one is definitely not the final thing I do. This is just getting started. And I'm going to do this on this side too. Oops. Certainly you can do 3 periods, bless you. Okay, now the next thing I do is the flip. And if you do that, the flip is easy. And some people just go for it and they would do the flip right from the beginning. So the flip is going to be my next thing. If you try to do all of this stuff, all 5 of these at one time, that'd be too much. So I'm going to get rid of that original one now. So that is the flip from the negative at the very front, the period change from the B, and the amplitude, which I didn't really write this down, but this is the A value right there. Okay, are there any questions about this before I move it? Okay, now we know we're moving it 1 space down. And it says move it pi over 4 left. Just yell out, how many spaces is pi over 4? Yeah, 1 space. Remember, there's 4 spaces. Divide this number by 4, and that'll be how long a space is. Okay, so take the 4th space and divide it by 4. The 4th space is at pi. Pi divided by 4 is pi over 4, so it's 1 space. 1 space, 1 space down, 1 space left. And 1 space is not hard to do compared to some of them. So I think it's a good idea just to practice, like, when you move a point down and left, cross it out and get rid of it so that you know you moved it. more organized you are, the easier this will be. And like I said, this is as difficult as they get. So if you're worried about them getting much more difficult, it shouldn't get much more difficult to understand than this. The illustration might get harder if you're moving at 2 or 3 spaces. But as far as like the understanding, that's it. Okay, so now I'm going to erase some of this stuff here. And if you have remnants of the stuff that was there, it's okay. I would write in pencil when you're doing your homework, which it's a worksheet I'm going to give it to you today. Oh boy. Well, I got rid of most of this stuff. Now, I got something wrong with mine. It's a minor thing, but what's wrong with this answer? So I know it doesn't say it on this directions, but it's going to say to graph 2 full periods. And so just have in your mind, like that being a rule to always do is have 2 full periods. And mine is not 2 full periods. Now yours might have a little extra over here, which is great. Okay. And that's this point right here that I didn't move. And we also said it's okay to just say, well, let's put this over here and put on this side. So I just want you to know there's 2 ways to handle that and put on either side. Okay, the next part says do the domain and range. Now for cosine and sine, the domain and range are easy because it never changes from all real numbers. The domain was all real numbers. The domain still is all real numbers. And then there is the change in the range. Range is lowest y to highest y. Okay. So there's 2 things that affect the range. Of these, you guys yell, of these 4 letters, A, B, C, and D, what are the 2 that affect the range, do you think? A is one of them. And D, A and D. Yep, A and D. A and D affect the range. That's the vertical stretch, which is the amplitude, and the vertical shift up and down. So I don't think it's necessary to do this like a formula, but I will show you because I want you to understand in a crisis or whatever what you would do. So you would say, okay, I have to multiply by the amplitude. So whatever the amplitude is, you multiply it. I don't know what symbol you want to use for multiply. I'll use like a star for multiplication, but you multiply by the amplitude. And remember, the amplitude is always positive. That's why I'm not saying times A. You can write times the absolute value of A. And that will give you -2/2. And then you add or subtract the D value. So then I'm going to write -1 on both of these. And that's from the D value. And it gives me -3 and 1. So do the amplitude and the D value to whatever your range was, and you could figure it out. I mean, you could literally look at the graph and be like, it obviously goes from -3 to 1, Mr. Raza. What's the problem? But people do that wrong all the time for whatever reason. So I'm giving you 2 different ways to do it. One is just look at the graph and be like, it goes from -3 to 3, or -3 to 1, or 2. Take the original range, multiply the amplitude, and then do the D, whether it's up or down. Any questions about this? Okay. So then I have the word frequency here. Use the word frequency a lot when you're talking about waves. And it's just the reciprocal of period. So when you're talking about period, you're saying how long it takes for a wave. Okay, you're saying every pi there's 1 wave. So it's the amount of time per wave. And then frequency is the amount of waves in a given amount of time. So as opposed to it's instead of waves, let me see if I say this right. Time it takes for 1 wave, it's waves over some unit of time. So it's just reciprocal. So the frequency would be 1 over pi. And, that's some decimal, right? Okay. Um, and like I said, that is usually used when you're talking about um, waves and you're saying like there's 300 waves per second or there's 100 waves per minute, something like that. Okay, flip it over or go to the next one. Okay, I'm gonna try not to go too fast on this one. Stop me if you have questions. The hardest part about this problem is the beginning part. Okay, you can't leave it the way it is. Okay, I'm gonna actually just rewrite it. So write y equals 4, and if it's like 2x or 3x, or in this case x divided by 2, you have to pull that number out, which would just be x, which would change that other number there. And what I told people is, whatever you're going to put there, do distributive property to check it. Okay. Now let's look at how to mathematically find it. It's division. You would do pi over 8 divided by a half. One way is to flip the second fraction and multiply. That's not the way I like to do it. I like to go like this. The common number between 8 and 2 is 8. So you multiply the common denominator, and the answer just shows up, pi over 4. And like I said, just a quick multiplication of these, and you should say, like, yeah, that's obviously going to be pi over 8. So no matter what answer you get or how you do it, just make sure you check it, because if that number's wrong, that not only is it going to be the wrong number that you're writing, but you might create a more challenging problem for yourself. You might turn your problem into one where instead of moving like half a space, you'll be moving like 4 spaces, which will be a totally different thing and maybe more complicated for you to do. Okay, so I do that. Then I would go down here and I would say, okay, amplitude is 4, period I haven't figured out yet. The phase shift is pi over 4 to the left. Domain range I'll fill out later. You go ahead and find the period. So the period here is 4 pi. Remember when the b value is less than 1, the period is getting bigger. And when the b value is greater than 1, it's getting smaller. So it's maybe opposite of what you would think, but remember you're dividing by b, so it kind of makes sense that a bigger number will make it smaller and a smaller number will make it bigger. That b value is never negative. It's not that it's impossible, I just don't do ones like that. And if it was negative, we would figure out some kind of way to deal with that other than drawing it in. That would be a horizontal flip. So there's no need to worry about that b value being negative. Of course, c could be negative. That would just mean move to the right. Okay, so now what I do here is I draw my initial sketch that involves the amplitude and period. I only need to go up 4 on this one because I know that this one doesn't shift up or down. The amplitude is 4, so it doesn't move up or down. No reason to go higher than 4. So 4 and negative 4 are good. Just by labeling those things, I took care of the amplitude and the period, So go ahead and draw what sine would look like. Don't do the phase shift. Do everything but the phase shift. No problem. That's yours. That your thing is yours too, right? That's all yours.
No, they're not mine.
Oh, I'll throw that here. Somebody else left that here. Okay. Okay. So sine starts at 0, goes up and over and down like this. This is just a quick sketch, but try to keep those key points at the right spot. I mean, mine would probably be better on paper. And really, what I'll be checking is those dots. Now you have to figure out, what direction am I moving and how far. So how many spaces is pi over 4? Do you think? Half a space, you think? Yes, I think it's quarter of a space. I think every space here is equal to pi. So you got to move it to quarter space. Now, it's just a little bit. Okay, so whether you divide these up into 4 pieces and do it is up to you. It doesn't really take that long to just sit here and go like, okay, let's split this into 4, split this into 4, split this into 4. It doesn't take very long. Obviously, some of those you have to just estimate. They're not on the axis. The ones on the axis, you can move it exactly that far. Moving every point. Pi over 4 left. Okay, so I'm going to use a different color here, but it's going to be right next to it. Let's see. It didn't have a dot there originally on that one. I think when the moves that are less than 1 space aren't too bad. I didn't even bother putting the X's on these because I'm pretty sure I keep track of a dot that's right next to it. And then again, erase this one. Okay, so the domain is going to be all real numbers. The range on this one I think is easy. If you didn't do the range, write it down. At least easier than the last one. And then I believe we just have this one more to do. I don't know, can we do this? How much time do I have? 9 minutes. I can do it in 9 minutes. All right, so this one goes from -4 to 4. Seriously, if you have questions, let me know. Everybody feeling okay about this? Practice makes perfect here. Um, I'm going to put a few of these things down quick and then I'm going to have you do the period. So the amplitude here is 4. There's no shift up or down, so that's good. The phase shift is going to be 2. And that is to the right because it's minus. So again, always make sure that we're doing the phase shift. It's just plain old x plus or minus a number, which it is. This thing out here, you don't want to distribute it. You want it like that. You want it removed from that binomial. And that is the b value. That whole thing's the b value. Okay, see if you can figure out the period here using that b. For all the people who got extra credit either from parent-teacher conferences or from the math contest, I put those in the grade book. And, that extra credit did change people's grades, and, that spread out over the next 2 tests. There's only 2 tests in there right now, so spread over 4 tests, it's not that much, but when you put in there and it's over the course of 2 tests, it seems like more than it might be, but it did help some people a little bit, which was good. Okay, so I would do it like this. I'd multiply top by 3 and bottom by 3. I'd cancel the 2's and cancel the pi's, which might seem like a lot of work. As long as you ended up with an answer of 3 and cancel the 3's, and as long as you end up with an answer of 3, you're good. On this one, if you flip and multiply, the 2 pi's cancel, and all you're left with is a 3 on top. The period is just 3. Okay, now, even though the period is 3, I am drawing 4 lines. Because when I draw my sine curve, I need to hit that middle line. So I'm going to draw this and label that a 3. Negative 3. Amplitude was 4. There's no shift, so going to 4, negative 4. So now you're just going to draw a sine with that amplitude. We're not doing the shift. Sine normally starts at 0, goes up to its amplitude number. So if the amplitude is 4, it goes up to 4. Then it hits the x-axis again and goes down to negative 4. The domain range, I can do right now too. Shifting up, down, left, right wouldn't change the domain. The domain's always all real numbers on these. I'm going to shift it right in a second, but that won't change the range from negative 4 to 4. And again, it's not always the amplitude number. It's the amplitude number plus the shift up or down, which there was no shift up or down, so I just left it like that. Now I have to figure out the hard part. I have to figure out how to move this thing 2 spaces. Do you see the problem here? Okay. I have 4 spaces, but it's labeled as 3, so each space is not equal to 1, and I got to move 2 spaces. All right. Now I can estimate 2 spaces. Okay, this distance right here is 1.5. Each one of these is 3/4, right? This is 3/4, and that's not super helpful to know. So I want to make more lines on here. Do you think it's helpful for me to split these all in half and make it so that there's 8 lines? Is that helpful or no? So if I split into 8 lines, then each line would be 3/8. Okay, 3/8. I mean, 3/8, another 3/8 is 6/8, another 3/8 is 9/8. Not really helpful. If I split these into 3, or draw, well, I started doing it wrong. I meant split into 3 and I didn't. If I'm split into 3, so drawing 2 lines, now I have 12 spaces altogether, and 3 divided by 12 is 1/4. Okay, now, okay, I have 1/4. So if I have 1/4, then I know that when I have 4 of these together, that equals 1, right? A fourth, a fourth, a fourth, and a fourth is a 1. And then another 4 of those is another 1. So then I can say, okay, maybe 12, this is 12. 12 is going to work. We're going to use this. Maybe now 16 is going to work because not this is by 3. So I had to kind of play around with it here and figure out a way to do this. I need to be able to count out 2 spaces. So I needed some number that was divisible by 3. Okay, I could have made it into 6 spaces, but how do you divide four spaces now into 6 spaces? I can't really do that, but I could divide 12 or 4 into now 12, which is a number that is divisible by 3. So I needed a number that is divisible by 3, so I have 12 spaces in there. I went from 4 spaces to 12 spaces. And now, when I have 12 spaces, and each space is equal to 1/4, because 3 divided by 12 is 1/4, I know 8 spaces left is going to do the trick. Or 8 spaces right is going to do the trick. So I'm moving every dot 8 spaces right. Did you follow all that? Yeah.
Why don't we just make 3 lines in the first place instead of 4?
Well, if you make 3 lines like this, right? Then when you go to do your sine curve, you might not know where that one hits. And it kind of goes through the middle, right? Which arguably is not too complicated to say it goes through the middle. We don't really know exactly where that is. So, yeah, I mean, that's not a crazy idea. For cosine, it might be a little bit more challenging because if you had cosine and you had 3 lines, you'd come up here and you'd end up there, and this one would be in the middle of these two, but like where do these hit? So that's the issue. That's the issue. And one way or another, you have to figure out you need you divide into 12 spaces. So I mean that's an alternate way of doing it. It's not totally wrong. All right, we're gonna move 8 spaces right. All right, here we go. So this is why you cross them out, because before you do it, when I use this one, see how it passes 2 dots? I passed 2 points on the way to moving that one right. So that's why you got to cross them out. And like when I move this one, I need to know, is that on this side of the y-axis, the other side? All right, the bell's going to ring in a second. I guess I couldn't do this one. But you get the idea for the rest of this. You just move the whole thing right, 8 spaces, and you're good. Wait, on your way out, you might want to get the worksheet. So you can do it. What's there? Grab a worksheet.
Yeah, it's the same one you gave us Friday, right?
Yeah, if you already have it, you're good. Thanks, Ray.